Do you know what a centroid and the center of gravity are in engineering mechanics? If you're not familiar with these concepts, let me explain them to you in simple terms. Understanding the centroid and the center of gravity is crucial in engineering, as they help us analyze structures and objects under different conditions. Let's start with the centroid. In engineering mechanics, the centroid refers to the geometric center of a shape or object. It is the point where you can balance the shape perfectly on a needle or a pin. Imagine you have a sheet of paper with irregular shapes cut out of it. If you were to balance that sheet on the tip of a needle, the needle would intersect the centroid of each shape. The centroid is essentially the average position of all the different parts of the object. Why is the centroid important? Well, it helps engineers determine various properties of an object. For example, when designing a beam, knowing the centroid allows us to analyze how the beam will deform under different loads. By understanding the centroid, engineers can calculate the moment of inertia and the section modulus, which are crucial in beam design. Moving on to the center of gravity, it is the point where the entire weight of an object is considered to be concentrated. Think of it as the balancing point of an object. If you were to suspend the object from this point, it would remain in perfect balance without tilting or rotating. The center of gravity depends on the distribution of weight throughout the object. Let's take a simple example. To understand this better, imagine you have a uniform rectangular block made of wood. The weight is evenly distributed throughout the block. In this case, the center of gravity would be right at the center of the block, as the weight is symmetrically distributed. However, if you were to remove a part of the block or add extra weight to one side, the center of gravity would shift accordingly. Why is the center of gravity important in engineering? Well, it helps us analyze how objects or structures will behave under different conditions. For example, when designing a crane, engineers need to ensure that the center of gravity of the lifted load is within a safe range to prevent the crane from tipping over. So in summary, the centroid and the center of gravity are essential concepts in engineering mechanics. The centroid represents the geometric center of a shape, while the center of gravity refers to the point where the weight of an object is concentrated. Understanding these concepts allows engineers to analyze and design structures with precision and safety.